We're going to tackle two topics with this particular video. They are the sound envelope and reverberation. Trying to take two useful tools. Sound envelope would really help us to start to learn a little bit more about some of those ideas associated with timbre that we talked about in the past. And reverberation, which is a great description of the way in which sound might bounce around surfaces in a space. And we use reverberation when we are trying to process sound, but we're also attending to what kind of reverberation is in a space when we're thinking about recording. So it's an important concept to have in mind. So let's move over to the PowerPoint and we'll pick up from there. Sound envelope and reverberation. So we'll start things off with the sound envelope. Basic question is, what are the parts of the sound envelope? We often think about them or relabel it as the ADSR envelope, with A, D, S, and R standing for the four different parts of the envelope. So those particular parts are given these names: attack, decay, sustain, and release. So what exactly do these labels convey? Well, let's dig into it. So the four stages, starting with attack, which describes pretty much as you would expect how the sound is created. So we're thinking about, let's say, a guitar, where you take the guitar and you have a pick perhaps and you pluck that string, and that action of plucking the string is what's providing energy and gets the sound activated, right? Creates the vibrations in the air. So that's our attack. And that attack can be really important to our understanding of a particular sound, specifically looking at the idea of timbre. And so the attack is that initial action, and we can see that in the sound envelope. We could see that the sound envelope for a flute looked different from that of a piano. Piano would have a hammer hitting a string and making it vibrate. That would look different than blowing across a hole on that small metal instrument, right? And when we looked at the timbre last time, we could see that the sound envelope for a violin looked different from the sound envelope for a bell that was struck with a mallet, right? So attack is going to be important, but also really brief. Following the attack, we're thinking about the initial decay. So we've got this application of energy right away, right, that generates that sound. And then there's this loss, an immediate loss of energy, so that envelope kind of drops a little bit in its amplitude. And that's called the initial decay. So it's the point where it's beginning to lose some of that energy. Then we have the sustain. Sustain is where we've got the sound sort of operating at a relatively constant amplitude. And that's where you're going to hear some more of the idea of the harmonics emanating from an instrument, let's say. So the saxophone sound, once that sound is started, it's going to be reverberating around inside that metal casing that the instrument is made of. And so there's going to be a period of time when that sound is kind of sustained. And then we get a release, which is the gradual loss of energy, and it drops down to becoming quiet again. One of the things I like to point out here is that people often confuse the initial decay and release, because the idea of release sounds like it's a diminishing of sounds, but then so does decay. And in this case, that's why it's really important to include the idea of initial decay, which gives us the sense that this is something that's happening relatively quickly, pretty much right after that attack is happening. But it's not an extended decay. It's something that's happening initially. So it's important to try to distinguish between those two. Here's a look at that sound envelope. So here you can see there's that really steep climb right away as energy is provided to that making the sound. Then there's a brief drop off in that energy. Then in this case, obviously, it's showing things generically. We have this nice rectangular look, nice straight line. for the sustain, and then we see there's a sort of exponential drop-off in the energy as time continues. So that is our sound envelope, the ADSR envelope. Now let's talk about reverberation. Reverberation is important to us because we get information about sounds through reverberation. One of the things that it does communicate to us is a sense of distance. So if we're using some kinds of effects, because we have somebody in a theatrical performance who's supposed to be far away, we want to convey that sense of distance. So we might use some reverb to help get them to feel like they're farther away, at least from the audience's perspective. We also sometimes are trying to create a sense of space. You know, lots of rooms sound different, and one of the reasons why they sound so different is because of the reverberation that's happening in that space. So when we think about reverberation, there are three categories of sound that we group the reverberation into. The first one is the direct sound. So the direct sound would be the sound that gets to your ears without going through any other things, not bouncing off any other surfaces. It just gets there fastest and most directly. So if we are in class and you're sitting at the desk and I'm talking at the front of the class, when I'm speaking to you, some of the sound is going right to your ears, and that would be the direct sound. Then we have another grouping of sounds that we call early reflections. These are sounds that get to your ear really quickly after the direct sound. In fact, usually we put in a little description of about 30 milliseconds as being sort of the delineation between those early reflections and that direct sound. So right after the direct sound hits, we're thinking about early reflections as being the sounds that come into your ear within 30 milliseconds of that direct sound. And so that's important to keep in mind because that's something that we're going to be manipulating when we process sound. We're also interested in the later reflections, and those are the reflections that get to your ears after 30 milliseconds. So when we were sitting in the classroom, if I'm speaking, there's sound, of course, that gets directly to your ears. Early reflections are going to be sounds that maybe bounce off the tabletop, the desk that's near you that you're sitting at perhaps. So it reflects off that, gets to your ears shortly thereafter, shortly after the direct sound, certainly. But then there's going to be some sound that gets to your ears after bouncing off the glass doors on the side, or something that bounces off the back wall. So those are going to be later reflections. And we get a sense of the size of the room just by hearing how the voices sound or other sounds within that space come across. And we can distinguish that smaller room from a cathedral because there's a different sense of reflection in that space. It takes longer time. The later reflections in the cathedral are going to linger longer, right? And so they have a greater effect on the overall quality of the sound. So I do have a little exercise for you to take a look at in the module here as well, just to give you a sense for some of the effect of reverberation in relation to times, adjusting the reverb time, and getting a sense for what does it do to the sound. But at the same time, I want you to pay attention to its effects on the intelligibility of speech in particular, because a lot of the things that we record in media is going to be related to speech in one way or another. And if we really understand the effects of reverberation on speech, then we also understand how getting a little bit further away from a sound source could have a negative effect on our ability to understand what's being said. So the quick review: direct sound, reverberation, it's the sound that gets directly to your ears without any kinds of other interference. The early reflections are usually coming off surfaces that are very close to your ears, and they get there within about 30 milliseconds of that direct sound. And the later reflections get there over a period of time. They decay relatively slowly, and they do give us a sense of distance and a sense of space that we're in. So that is the sound envelope and reverberation. That covers this particular video.